Hey, this is Robert Naini, your spray foam advisor, and today I want to talk about combustion appliances. Now, we work in all types of structures and all type of buildings. Do you know when there are combustion appliances on the properties that you're working on? It's very important that you do, because what happens is we change the dynamics of buildings. We change the way structures work fundamentally at an air leakage level, right? Of course, we provide insulation value, but the number one benefit that we provide is by providing that insulation and air barrier in the same application with our spray foam insulation products. Well, by providing this air barrier with the spray foam insulation, we're changing the way the air moves through structures. We're changing the pressurization of a building. We're changing the natural airflow inside of these structures. So it's critically important that we know when there are combustion appliances in these buildings, where they are and where their combustion air is coming from and where their exhaust fumes are being sent. This is all important and comes down to something called CAZ safety. This CAZ, C-A-Z, stands for Combustion Appliance Zone. And when you have something like a water heater that's gas, or a gas stove, gas furnace, any gas appliances, these are combustion systems that require air as part of the combustion process. And when that combustion event occurs inside the system, it creates CO2 and moisture, and these components are contaminants to the home, and they have to be exhausted to the outside of the building enclosure. So if you're changing the building enclosure by bringing in spray foam insulation, it's critically important that the CAZ safety and CAZ awareness, the combustion appliance zone awareness, be critical to the process, whether you're doing it or the general contractor's involved in that process, or they bring in some appliance expert to be involved in that process. Someone needs to be responsible for the CAZ operation, and that's the combustion appliance zone, and really it's those combustion appliances in the area that you have to be worried about. So let's take an example. We have a traditional attic space, and up in that attic we have a water heater that is a gas combustion water heater. So we have a gas water heater up in the attic, and you as a spray foam contractor are coming in to create a closed attic assembly in this retrofit environment. What happens next? So what happens overall is you are putting insulation and air barrier components, these building enclosure layers, right? These control layers for the building enclosure, you're putting them on the underside of the roof deck. You're creating this unvented sealed attic assembly, and now you've made the attic part of the living space or part of the building enclosure. It shares the same types of pressures as the living space below. So what we have to make sure is that this attic space, which has a combustion appliance in it, it is now a combustion appliance zone. And that combustion appliance zone needs to have its own safety precautions. And specifically, we need to make sure that the fumes, that the exhaust from this combustion appliance are going from the vent hood and out of the structure to the exterior. We need to make sure that it's not backdrafting inside the structure and bringing these contaminants into the building enclosure. So it's critically important that we're aware of this process, aware of the safety precautions when it comes to gas combustion appliances. So there's a couple of ways that this really happens when we're dealing with gas combustion appliances. In the modern, the newer types of gas combustion appliances, especially in the high efficiency systems, what we're seeing is sealed combustion units. And sealed combustion units is exactly what it sounds like. The combustion process is happening internally, and the exhaust, the intake and the exhaust is all part of a sealed loop, part of a sealed system. This most often happens, for example, with a water heater. It will be a double sheathed pipe or a double wall pipe that the intake is coming through the pipe and the exhaust is going out through the pipe, and they're just separated by the walls inside the pipe system itself. So that's one of the more common scenarios of how that's managed, how that's dealt with when we're dealing with newer appliances that have some of the new technology, new designs on them. But when we're dealing with older less efficient systems. When we start talking about, standard 80% efficiency furnaces, a lot of these are open combustion systems. These are not closed combustion systems. So these open combustion systems, it means that they're drawing air from the space around them, and that air is being used as the combustion process inside, as part of the combustion process inside the appliance, to create the heat that they're using for the work that they're doing, right? So then that process creates the CO2 and the moisture that I talked about, and those contaminants have to be exhausted to the outside, to the exterior of the building enclosure. So that venting has to follow IMC requirements, the International Mechanical Code, and has to be to the exterior of the building enclosure. You actually may or may not know about this, but if you go check any ES report for any product that you work with, and you look at any of the special criteria for intumescent coatings or leaving foams, closed cell or open cell foams exposed in attic spaces, one of the bullet points, one of the requirements is that any gas combustion appliances in the area follow the required ventilation strategies of the IMC for that appliance. So if you're not aware of that, pay close attention to it, because if for some reason a gas combustion appliance is not properly vented to the outside, technically you're in violation of the IMC, and you're in violation of that section of the ES report that you're working with, which means that you now have to have an ignition barrier from the code over all of the material, rather than following the alternate approved by that ES report that you're working with. So that's kind of a caveat to this, but it's important that you're identifying these gas combustion appliances, because certain criteria have to be, some safety precautions have to be taken, and you have to make sure that that the exhaust is managed properly. And if you're dealing with 80% combustion units in a huge attic assembly, you may not want to have that penetration, have the exhaust to the outside in that huge attic assembly. So you may end up creating a mechanical room around this gas combustion appliance, so that you can then bring in fresh air to that space and exhaust from that space when you're dealing with these open combustion systems. So oftentimes that's going to be some type of enclosure around that mechanical device, that gas combustion appliance, so that you create a separate environment, a separate room that can then be vented to meet the best requirements of the code without violating the closed attic assembly or the unvented attic in that building enclosure. So that's some of the concepts related to gas combustion appliances and how it affects combustion safety in structures. So be aware, new term for the day, CAZ, combustion appliance zone. Make sure that you're aware of the combustion appliances on projects you're working on, and know what you're doing to the building, how the building physics are going to change the way the structure works, and what that does to those combustion appliances. This has been Robert Naini with Spray Foam Advisor. Thanks for checking us out. Catch us on some more videos. I love questions. Anyone out there, feel free to shoot in a question. I'll give you an email address right here for any questions you have. Send them to questions@sprayfoamadvisor.com. sprayfoamadvisorsingular.com. So questions@sprayfoamadvisor.com. Go ahead and send those questions in. I'll get to as many of them as I can, and I'll try to incorporate a select few into some of my weekly videos. And of course, if you like this video, go ahead and subscribe to the blog if you haven't already done that. Find us on YouTube and like and follow us there. And check us out on LinkedIn, Facebook, Twitter, Instagram. Find us on all of your favorite social media sites, and you can keep up with the words of wisdom coming out of Spray Foam Advisor. Thank you very much for joining us. I appreciate it. We'll catch you on some more videos. Take care.